And we also liked that there were all these great official and community images. You don't have to reinvent the wheel unless you really want to. You can just say from Ruby, from Go, from Java, from Python, and you've got this environment that's pretty close to what you already need. And then you can crack it open on the registry and see exactly what their Docker file is, copy, paste it, tweak something, whatever you want to do. And then for hosting choices, it's kind of funny to say there's pretty low lock-in because you're getting locked into the Docker way, but at the same time you can run your own registries. There's lots of people who are starting to support Docker, so the vendor that you pick you're not particularly locked into, and a lot of this stuff you can run yourself if you have to. So what are our options for doing Docker CD? You can do CD in a lot of different ways. It doesn't always mean that you're just running it on some product that you pick. So the first way that you can do CD actually is completely off of your local machine. There's nothing really stopping you from saying, on my laptop, I'm going to run the tests, and then when they pass, I'm going to build the images, and then I'm going to push the images, and then I'm going to trigger my host to pull down that image. That's still CD, really. It's still shipping small pieces and shipping it fast. And it's actually the simplest way to get started. The issue is that if you're running all this stuff on your little laptop, hopefully you've got the same environment as what you're looking at for production, and then also your, I mean, at least my laptop, it's nice and light, but it's pretty slow, and I'm on the Wi-Fi. And when I'm working with other developers, who knows what somebody else might be doing on their laptop. So you've got these race conditions in terms of pushing and triggering deploys, because if I push my image, then someone else pushes theirs, but then I deploy first, all of a sudden I'm deploying their code, and that can be pretty confusing. So the second option is to look at hosted continuous deployment with Docker. So in this case, let's say we just start talking about something pretty simple like Jenkins, where you're running it yourself. You've decided you're going to host it in a central location for your team. The issues that you have there are figuring out how to cache that information and actually leverage Docker's cache between all of your builds. And then making sure that when you're running all of this stuff in your containers that you do still have production parity. Because what often happens when you're running your CI is that your testing containers look a little bit different from what your production containers look like. So you still have to keep track of that yourself, and we talked about that a bunch in the open session yesterday. Then also when you're building those production containers, how are you handling multiple containers? And that sort of depends on which hosted one that you pick. But it was just a good thing to think about, because there are a bunch of Docker-based CI solutions out there, ones that you run yourself, open source ones, and hosted SaaS products, where what they're doing with Docker is allowing you to use Docker to define your environment for your build, but not then letting you do Dockery things like building lots of stuff and running compose and pushing images and all of that. So we wanted to make sure we had flexibility there. And then with the host, it's similar to local, where you're pushing your images up and you're triggering your production environment to deploy. And then the third thing we considered was a custom solution, because, I mean, we're developers. We can always consider a custom solution. Problem is, who knows what that is? It's whatever we feel like building. So that can be anything. So what we really tried to focus on thinking about is, what are we missing? What is it that we need that we're not getting right now with what's available and out there for Docker continuous delivery? So we went to build a centralized continuous delivery system for our team, and these are the goals that we had in mind. Coming back to the same ones, that parity. That means that we wanted our CI containers to look a lot like our production containers. So that way we would know if the tests pass in CI, it's going to be in the same environment when we go to production. In practice, this is approximately equal. We would try to get as close as possible, but they're always going to be a little different for good reasons. So one of the things we would try to do, though, is stick to the same from. Stick to that same base image, and stick to the same OS packages, maybe add a couple more in test. And then also be linking our services. So I think the monolith container idea has been declining, which I think is a good thing. But at the time, we were trying to decide between, do we want that big container that runs multiple processes under one init process, or do we want to do linked containers? And we realized that the linked containers was much closer to what production looks like, because you have your database over there, and you have your cache over there, and then here's my app. And it's the app that's coming in anew. And so keeping it linked means that the app container is just the app. And that's more similar to, in CI, to what you have in production. And then our hosting stack had to be Docker. So we can't do CI in Docker and then not deploy to Docker, because then that parity is really destroyed. So this was sort of a clear one, but I wanted to point it out as well, that sticking to that same host base is pretty important. So then the other goal that we had was the orchestration. So that means running the tasks we have to run for CI and linking the services and keeping everything all running and coordinated, and being able to then collate logs, exit codes, all that stuff. So the first thing we looked at was Docker Compose, because Compose does links for you, and then it allows you to run a bunch of tasks. So another goal here was, and something we were trying to figure out, was how to do multiple compositions. So being able to say, Compose run my unit tests, Compose run my integration tests, Compose run my acceptance tests, have those configurations be similar but have different goals and different dependencies. And the other goal that we had was that speed. And for us, that meant the Docker cache. And speed really is critically important. I think if there's one thing that you feel the most pain on when you're working with continuous integration, it's when the build just gets slower and slower and slower, and you cannot ship that one little one-line change. It's like, I spent 5 minutes making this change, it's taking me hours to get it to production, and that really stinks. So we wanted to have a special focus on our speed. Okay, so talking about speed and caching, let's talk about base images. So it was important to be able to use the layers from last time, from the previous build. If those aren't present in the Docker environment, then you aren't able to leverage the Docker cache. So what that means for us, the way we thought about it, was registries. It's a really natural way that Docker stores images and transfers them around, and the Docker registries all do this in a layered way, naturally. Our other goal towards speed is parallelism. We wanted to run a bunch of stuff at the same time. This is always really hard, and we were not really sure what we were going to do about this, but we'll talk about it a little later. But the nice thing was, we knew that when it came to parallelism, we had Docker's isolation. So when you run containers on Docker, you can run a whole bunch of the same thing, and they all get virtually mapped to different places, which meant that we at least knew we should, in theory, be able to run a bunch of stuff in parallel and have them not collide with each other. But that's always what you say at the beginning when you start doing something in parallel. So that meant that we needed the orchestration. We needed the orchestration of our linked applications and their linked services and the tasks we were running, but then on top of that, we needed orchestration of orchestration, because we had to parallelize Docker Compose. And when you're looking at one of your builds, you could have a lot of pipelines and a lot of nested pipelines. So in this case, we've got the checkout that happens at the beginning, and then maybe we have static analysis that might break into a couple different parallel tasks like linting, style checking, and security analysis. When we go to do our CI phase, we might have a couple different Docker builds, in this case A, B, and C, and then in here we've got like a bunch of different steps. These are like 4 unit test groups, 3 integration test groups, and 2 acceptance test groups. Then you go on to continuous deployment, and you might need to build production images and push and deploy those separately, and then collate that back together to pass your build, your deployment. And then what happens is, even if you look into just one of these, if you break one of them down, that acceptance test has got its own app, maybe an API that it uses, a database, the cache, and the tests. So this is what I mean by orchestration of orchestration. We've got all these pieces going on, and then each piece breaks down again into a couple of pieces. So it's quite complicated. And of course, since we're CodeShip, we were like, let's build it, because this is our product, this is what we do, and we were like, let's make this awesome. And the alternate title for Let's Build It is What We Learned and What Went Wrong. So I'm hoping to share a bunch of the things that we learned along the way, a bunch of the ways that we tackled some of these problems, and also just to share some fun stories about trying to get Docker to work. Okay, so the first thing we knew we had to do to get one of our apps doing continuous delivery with Docker was to come up with what all of our containers look like. So there's all these great official language containers, like I mentioned before. And I would say try to use them if you can. They dictate the OS. They love Debbie and Jessie. Maybe it's because Jessie Frizzell likes to base things off of things named after her. I'm not sure. But Debian is great, but sometimes you're not on Debian. Also, they're big, and the pull is going to be slow, and they're going to use a lot of disk space. And especially if you're virtualizing your Docker environment, like with Docker Machine and VirtualBox, big images can get pretty painful when you're in development mode. And keeping development mode parity with CI and then to production is pretty important. It also meant that for CI and while we're doing CD, when we had to pull these images down, that could take a while, and then we have to push them over to our production environment. That took a while as well, and speed was pretty important to us. So containers for CI, when you're building these, the code changes a lot, right? Because that's the whole point of CI, is the only time you run a build is when the code changed. So the code pretty much always changes. And that means you're going to have to be doing a lot of rebuilds all the time. And we found that our dependencies were the majority of time when we ran our container builds. And the dependencies only change occasionally. And by dependencies, I'm talking about your third-party libraries that you use in your application. So Maven, Bundler, pip, npm, all that stuff. So the first hack I wanted to share is layering dependencies. This is one of the first things you sort of figure out when you start building your Docker images to dodge this problem, is that you can use Docker's cache in a particular way to be able to control when particular things get cached, and the ordering in the Docker file matters a lot there. So what we have here in the first section is the classic way you create your app inside of the container. You add dot, you add all of your source, and then you're going to run your dependency thing. That might be a make task, it might be bundler, it could be Maven, npm, pip, so on and so forth. And then your command is, let's run my tests. So what layering means is you're going to break that into separate adds. You're going to add whatever your dependency manifest is. So in the first example here, that was adding your godeps in, or adding your gem file in gemfile.lock. Then run your dependency command, and then add the rest of your source in. And what happens is the add in the layered one is going to be cached against the changes of those dependency manifest files. So if your dependency manifest doesn't change build by build, you can use the dependencies you installed from previous runs. So this is great on CI because it gets us boosted all the way through that phase, and then we only have to do that real big build when we change our dependencies. So when you upgrade versions of libraries you depend on, you have to install them again. And it's really fantastic on a development machine because the development machines are usually a little less powerful than your CI machines, so this stuff takes even longer. Okay, hack number 2, using registries for continuous integration. And we talked about this a little bit in the open session today, but I'll go into a little bit more detail today. So what this means is that before I run my CI build, I'm going to pull down the image for my app under the tag of the branch that I'm working on. So if this was a build for my feature branch, like feature make the button green, I'd be pulling down app : make the button green, like with dashes, like a branch name. So that would be my build from my previous CI runs on that branch. So I'm going to pull it before I run my CI build. And you might be thinking, where did it come from? The trick is that we're going to push it after we run our build. So let's say you're building on master, right? And this isn't your very first master build. Your very first master build gets nothing. It has to build everything up from scratch. The second time you build on master, that first build pushed up all of your images to the registry under app master. The second build will go back and run the pull of app master, and it gets all the layers from the previous run. And they're just in Docker's var lib docker as layers. It's not like you are explicitly telling Docker, use those images. You're not. You're just saying when you tell Docker to build, Docker's going to go, oh, hey, look, this looks exactly the same. I'm going to use it. Because that's why the Docker cache is awesome, is it's automatic. So we pull it before CI because after the last one, we pushed it up. And the thing that I don't mention here is that one trick that we've added is that when you're doing the first build on a new branch, if you can't find the branch when you pull, we fall back to pulling master. So at least we get somewhat a pretty close layers. All right, and as part of this, running the registry near CI is really important. You can use the Docker Hub. Docker Hub is great. It's really easy because it's already there, but you don't have to. Docker's registry is open source. You can run it co-located with wherever you're doing your continuous integration. You can run it on AWS. You can run it on your own servers inside your VPN or your network, whatever you've got in your VPC. And if you wanted to, you could even run it on the CI machine right next to CI. You just might need to clean it out and watch your disk. So the containers that we're building here for production, it was a goal for us, like I mentioned before, to have them be the same as the CI, except maybe minus a few of my testing packages. So again, the layering and common bases helps here. So having your production containers and your CI containers really start from the same place and diverge much, much later means that the parity is better, but it also means you're using all of those cache layers from when you were doing your CI build. So when you go to build your production container, you're leveraging your CI's cache. So really, if you set your layers up really nicely, a lot of things fall into place for you. So when you're actually deploying your containers to production, one of the issues we faced was that the bigger they were, the slower it would take us to get them from CI out to production. So now we've got this magical environment, we've got CI, we've got a registry right there, our CI builds are running really fast, and then we go to run our deploy, and it just takes ages to ship it to where it actually needs to be. So one of the hacks we played with here was static containers. So what do I mean by a static container? I mean when you're running your CI, before you build your production container, you're going to make some sort of production binary. Then when you build your production container, you're going to build it in the current directory context, which means that binary is available. So when you build your production container, you can say, okay, I'm just going to come from Debian. Maybe I need a few dynamic libraries. I need CA certificates or some, can't think of a good dynamic library off the top of my head. Then you're going to add that production binary into your container, and your command will run it. So what this means is that that binary was not built by the container. It was built by you and then added into the container. So now what that means is that we only need the minimal number of packages to run our binary. It's the same sort of thing when you curl a binary down from somebody and you didn't really need to build it yourself. You can just curl it down because they built you one for your architecture. That means we don't need any language packages. So over here, you don't know what language I wrote this in. In my Dockerfile.production, I didn't have to say from Java, from Ruby, from, well, not Ruby in this case, like from Go or C or something like that. Now, that only works for compiled languages, of course, so there's only a couple of those that people are running most of the time, but there's certainly gains for a VM language, because for VM language, it's the same sort of thing, except you have to add one more package, you have to add the VM runtime, but not the SDK. So it's like using a JRE container and not a JDK container to run in production, and that's probably something that everybody who knows Java is already like, well, yeah, of course you wouldn't put the JDK on your production system. That's silly. Why would you do that? But for us, when we were first working with this stuff, we were coming at it with Go, and so we thought this was pretty neat. Okay, so hack number 3, point A, was scratch containers, and these are just really, really fun, so I had to share. We don't do this anymore, but it's very cool, and if you can get away with it, it's got some benefits. So what is the scratch container? It's actually just an empty tar. It is the Docker null container. So again, we're going to make our production binary, and we're going to build it for production. But what we're going to do is say from scratch, which means there is nothing in there. And we're going to add our binary in and run it. So there's actually there's no OS, there are no libraries at all. And these are hilariously tiny. They are single digits megabytes. We've deployed 6 meg containers to production and run our services on them. And that's pretty cool. The issue is it only works for languages that can statically compile fully. not even be dynamically linked to libraries available at runtime. And also, you have the worst CI to production parity. So we really sacrificed one of our goals for this, but you have a near instant push, pull, boot, and deploy. So if you've got a Go application and you're building it statically and you're shipping it out and then you're running it, that thing goes from being, hey, the build's done, let's deploy, to running in like 4 seconds. It's pretty amazing. Yeah, you had a question?
Why is it the worst CI plus Progress?
Because in CI, you're not running a statically compiled binary against your tests, unless you are, and you could. But in general, you are.
Yeah, so we use this model.
Then go for it.
We do, and it goes through exactly like you said.
Yeah. Yep. So if you take that statically compiled binary and that's what you use to build up and then poke at with acceptance tests, then you're doing okay. Yeah, for sure. I'm talking more about, I guess I would think about it more with like unit tests, right? Where I'm like unit testing inside the library and hitting against the test database and stuff. So, but yeah, I'm glad you brought it up because that's something you just have to be aware of and be paying attention to and realizing, hey, unless I'm actually testing the static binary I'm shipping, then I'm missing that parity. But awesome, that sounds really cool. Okay, so then we can't all do this magical static compiled stuff. Even at CodeShip, we've got some things that we can compile, and we've got some things that are interpreted languages that we have to ship. So I wanted to talk about minimal guests. So a minimal guest is the base for a container, and it's the smallest OS that you really need to be able to set your container up. Minimal toolchain, minimal packaging, and a bunch of do-it-yourself. And these give you small containers for the more dynamic language crowd. So there's a really cool project called Alpine. It's like, I think it starts at like 12 megs or something like that, but it has a package manager. The thing is though, as you bring in the packages that you need, that's really where a lot of the OS weight is anyways. But it's a pretty cool project and you can make some pretty small containers. So this is a 16 megabyte MySQL client container from Alpine. And all you do is you say APK update and add the MySQL client, and now this container can interact with a already running MySQL database, and it's only 16 megs. So you can make these pretty small. I'm hoping we have a lot more options. I think it would be really great if we could take real OSs that are used in production, like Debian, CentOS, and strip those down even smaller. It'd be amazing if somebody said, hey, there's a 30 meg Debian base you can use. I would love that. I think Debian's around 95 megs right now, which is still pretty good. And then one quick example here, if you want to take a look at what like a real one looks like. We have one for Ruby, and we went from 718 megabytes with the official Ruby one down to 349 using Alpine. And Ruby, it's interpreted, it needs lots of libraries going on, so I wouldn't consider this small, but it's smaller. So there are gains that you can get by using those minimal guests and really fine-tuning this stuff. Okay, so let's talk about orchestration again and Docker Compose, because this is how we ended up trying out how to run all of this stuff. And when you're using Docker Compose to run your tasks, you end up having these separate services, and you can link them together. So in this case, the application builds off the current directory using the Docker file. It's linked to this database. It's going to expose port 8000, and the database is just going to be an off-the-shelf Postgres. Now, if you want to run something in CI to run your tests here, you can say Docker Compose run app, that's the service, then make test is the test command. And here you can have the CI running with these linked services separated. And this was really, really cool to get this up and running, because it really felt like we had this powerful way of describing our CI infrastructure with a whole bunch of dependencies as well, and getting that stuff to build on the fly. But we had a couple of problems. First one is, and this is still an outstanding issue, you can't really tell when those services are running. And I'll get into that a little bit more in a second. The other one was environment encryption. So being able to have a safe way to share these environments, either if it's within your company or with other companies, and keep your secrets secret during CI. And then this comes back to the orchestration of orchestration. It was difficult for us to run a lot of composes all at the same time with services that were all named the same thing. So what happened was, when we were building this, we ended up having to manually run and link it. So that means we would run a Postgres, we'd name it unit test group 1's Postgres, and then we'd have to sleep for a magic number to wait for Postgres to come up. And then we would run and name our unit test group, link it to that unit 1 Postgres, make test, finish that up, check its exit code, and tear down U1 Postgres. Although recently Docker is working on getting the Go project libcompose from the amazing Rancher guys who are here. I don't know if they're here, but they're around, which would make using compose as a library a lot easier. It's still in Python, so you still have to just call stuff to use it. But we ended up having to do this, which was a little unfortunate. And then when it came to parallelism, that means you have to manually run and link these things and then namespace them inside of their parallel groups. So the orchestration of orchestration was getting to be quite a headache, which meant that you really have to run your own agent here to split the work, monitor all those containers, and at this point you've pretty much invented a hosting platform. So that was a big pain. But we'll figure it out. Okay, now the other cool thing we realized is Docker Swarm, the way that it works is it brings up a bunch of Docker machines, but it makes them look like one Docker machine, one endpoint. So that meant that we knew that if all we needed as a dependency for our CI was Docker, Swarm would give us machine parallelism for our CI builds at very, very little effort. And that was really cool, so we were really looking forward to this. Okay, so coming near the end here, let's talk about deployments. So there's a lot of different deployment styles. When you finished up your CI part of your build, and it's time, you've got all these things built, all your images are ready to go, all of your tests pass, it's time to ship. So there's a couple different styles. There's the push the code up and build it on the host. Deis has the ability to do it this way. Elastic Beanstalk is like this. This is like the Heroku git push, and then your deployment happens. The other one is where you build your images and you push your images up to a registry, and then you trigger something on the host. And Deis is in this list as well as Elastic Beanstalk, Elastic Container Service, Google App Engine. You tell them, hey, go pull my thing, here's credentials, pull this image down, run it. And then the third one, and I tossed this in just because Heroku's got this new Docker beta platform thing going on, which is they will take your images that you build and then cross-build them into the Heroku slugs and push those up. So there's some other hosting providers out there that have just created these compatibility layers for Docker images that turn it into the artifact that they're used to using. Okay, so let's talk about building on the host. That means that your CI doesn't have the burden of building your images. It means that your Deis cluster is going to build your images. For the most part, when I was looking at the solutions here, it had to be a single Dockerfile app. Like Elastic Beanstalk, it says, if you want to just push code, we're just going to build whatever the Dockerfile is in the root. It's got to be ready to go just like that. None of this crazy building a binary beforehand sort of stuff. And it's got to be, since it's that one service that's getting deployed, you only have that atomicity of a single service on your deployment. So you really have to just be able to deploy this thing in isolation. And you can't leverage the cache because you're over on some Elastic Beanstalk EC2 machine, and you can't manipulate the cache at that point. You can't do your pulls. If you're doing the build and then push and trigger pull, that means that you have your local cache available. Your CI is going to do those production builds for you. And the push and pull is going to add time because you've got to ship that whole image across as opposed to shipping just your source and having it built wherever you are. But since we've been talking a lot about making those images small, that was more appealing to us. And since you're in control at this point, you can push a lot of them, you can launch a lot of them together. And then build and cross-build, I don't really know how all this works. I don't have a lot of experience on this one. I just wanted to mention it because I think a couple vendors are doing it, and it seems pretty cool, especially if you're already using them. You can just say, we can adopt Docker, and then we can keep using the hosting provider we have and not make the ops people angry, and just ship our stuff over and it'll get converted. Okay, so the fourth hack here is using the same registry like everywhere. So having that registry near your CI, but also having it near your hosting provider, and pushing your CI layers, tagging them during the CI process, having them be available for CI nice and quick like we were talking about before. And then that means that your host, if it's already got your app and it's got your layers, only the layers that need to get shipped across to the host during the deploy are going to need to get shipped. And if that registry is also near the host, those pushes and pulls are very fast as well. So again, leveraging those layers really, really well, so you have these really strong, slow changing bases, and then the hot layers at the top that are changing a lot with a lot of churn. That means when you're going from CI into your registry, into deployment, only those top layers really have to move around, and Docker takes care of all that for you, which is really cool. So trying to use similar bases here also makes a lot of sense. If you base all of your apps off the same core base, maybe all you mean by that is Debian or CentOS at a specific version. That means when all your services ship around, they're all using the same base. You don't have to pull a lot of big bases just to deploy one group of services. All right, so keep them close, and in our case, that meant just Amazon all the things. Okay, so what's next? Where are we going now that we've set this stuff up? Some of the things we were really looking for, and are still looking for, is better parallel tooling around a lot of this stuff. And I think it'll be interesting to see where Docker Compose and Docker Swarm go, and if they're going to start working together, especially after the Tudum acquisition. There could be some neat things that they're working on there, but I don't know. It's all secret. I wear the shirt, but I literally have no inside information. So sorry. But I'm hoping that that there's a lot more that's going to come into play there as they grow and they start tackling bigger problems around the parallelism tooling. And then also, I'm hoping for some better development environments. Running Docker inside a VM is pretty difficult, and I'm hoping we get some non-virtualized Docker drivers for more and more platforms. I know Microsoft's working on that, having one native, and then on OS X that's still difficult as well. And then machine provisioning. So when we're actually building up our CI machines, we do this immutably, and so we want to be able to boot up a machine that is running Docker, so we can start our CI build on it. And Docker Machine right now isn't really a production tool. It's more a development tool, or when you're working through the tutorials, when you're setting up those systems, they tell you, yeah, you probably shouldn't be using this in production just yet. And it's also, again, it doesn't have an API, and it's in Python, so you can't, unless you're in Python, you can't leverage it in any way. And even at that point, the code there is library oriented, not API. Or I'm sorry, no, Docker Machine is in Go. Docker Machine's in Go, but they don't have it architected in Go in a way that you can use it as a library. It's just meant to be a CLI. But I think that might be an area where they're going to be improving as well to help people get this stuff running in production. That helps with CI too. Okay, so last thing I'm going to plug is that we have been working on this stuff for a long time, and it's not generally available just yet, but it's not in beta either. So you can check it out there on CodeShip's site, or you can just come say hi to me and we can talk about it. We've been running this for ourselves and a couple of big customers for a little while, and happy to share more information about that with you, but didn't want to just, sales pitch you for 45 minutes. All right, thank you very much. So I believe we have 5 minutes for questions, and I also wanted to share a little coupon code for CodeShip. So we're really happy that you all came out to ContainerDays, and if you want to take a little coupon off your CodeShip bill, NYC ContainerDays 2015. Yeah, questions? Yes.
So the last slide you had on the provisioning bit, do you see people using alternative tools like Ansible or Vagrant, things that maybe are a little bit better tool to actually provision resources?
Yeah, exactly, and that's what we do. I think it would be really nice from the parity perspective to be able to say, oh, you just got started learning Docker. Use Docker Machine, it's the easiest way to get going. Okay, cool, you figured that out. Let's get your app running on CI. Guess what? We use Docker Machine, which means if it worked for you, it works for us on CI. Okay, cool, now let's deploy it. Well, we use Docker Machine for deployment. If it worked for your machine and it worked on CI, then it's going to work in production. So being able to use the same thing is very useful there. So if you're using Ansible for development against a Vagrant box, then you're using Ansible for your CI provisioning, then you use Ansible for production, then you've done it. So I think that would be a great way to do it. It would just be nice if the first party Docker Machine had the ability to extend all the way through the stack, was my main point there. But yeah, using one tool through the whole stack is very powerful. Thanks.
The latest Alpine, by the way, is 5 minutes.
Wow. See, the thing with Alpine is the latest is really small, but as soon as you start installing stuff, you kind of creep up to where you were going to be anyways.
Yeah. This is for you to give away.
The tile?
Yes.
Okay. All right. Who else has got a question? Yes.
You mentioned that if you're on a new branch, you want to pull down from master so that you don't have to rebuild that branch from scratch, right? Why don't you pull down necessarily from the parent branch, but if the branch parent is not master?
Yeah, you can do that too. The trick. So the trick is that we did this outside of the checkout. So at the time where we did the pulls and pushes, that was pre-code checkout. So we didn't have Git available to be aware of who our parents were.
Okay.
That was all. But generally, like, unless you've got some really long branches going, if you've done your layers pretty well, the master's going to have a lot of that stuff.
Right.
It's just if you start really getting off into the weeds with some really big updates to your dependencies. But again, it's only that first time there's a new branch. You have to suck it up. So
and every time you just upload the image back and just grab that image.
exactly, yeah. Once you've done that first one, you're good. And at CodeShip, it just happened that internally, we often open the branches and open the pull requests pretty early so that we can start reviews and get feedback on the work we're doing before we're done, when we're at the beginning. So you end up opening these things that you know the build's going to fail because you really just started on it. And you just sort of let it go and build up so it's ready. And then as you work along, it gets a little closer to where you want to be.
Yeah, I know a lot of first build failure. Just working at it.
Yeah, I mean, and sometimes you just check it out to make the branch and then you push it and nothing really changed, but you just sort of got everything going and you open the PR, you talk about what your goals are, what you're going to do with it, you have the discussion with your teammates about your different solutions, and for us that's a communication point. So we try to do that a lot early. Yeah. Thanks, you just want a tile.
All right.
Yeah. Your CI machines get really filled up with Docker images.
They're immutable.
Which you may be totally done with and don't need anymore.
Our CI machines are immutable. So we launch them per build and we terminate them per build. And that's also because we provide full root access on the machine and give you privileged Docker so that you can run Docker stuff while you're inside a Docker build. So in order to give that much power with the security concerns with Docker right now, I mean, I don't know if there are still existing security issues, but I'm not a security expert. So we just have our machines terminated afterwards. So we use the registries as the place to keep all of those images around, and we let Docker deal with that.
Question that layer. Does your registry
Yeah.
get really full of crap that you don't need anymore?
We haven't started using a co-located registry for our CI product yet. We're hoping to use the Amazon first-party one. We used it for a little while we were working on it, but then we ended up transitioning over to using a hosted one. But now we're feeling a lot of pain from using a hosted one, and we want to move it back for a lot of the reasons that I talked about. And so we've been going back and forth, and yeah, but that probably will become an issue. But like I said, I'm hoping we can use Amazon's registry product because I'm hoping it's going to hit GA pretty soon. That'd be nice.
But regardless of it, just you run it yourself, or if it's hosted, it's going to get filled up with lots and lots of stuff.
Yep. So the nice thing is because the way we structured our tags with the branch name, with the app name, that means that once we've got those, we can clean out everything that's not needed by the current tags because we don't need those old untagged layers anymore. And since we're re-tagging with those branch names, it helps us keep that in check, I guess. But then, yeah, you would still have to go back and clear out the branches when they got merged in. But we don't have a solution for that yet. All right, well, that's it for me. If you have any other questions or you want to talk about CodeShip Docker or just cool testing stuff, stupid Docker tricks, I always love those, just come say hi. Thank you. Good.
Docker tricks. But
That?
I could imagine I don't have 45 minutes of stuff. I wish you had. Yeah, that'll be great. Yeah, everybody just share. That would be great.
All right, well, if you're stumbling in and don't know what you've gotten yourselves into, what we'll be talking about this time is what it really takes to build a container platform, or 10 things that we learned the hard way. All right, all right. I'm Matt Butcher. I'm the platform architect at Deis. My main area of responsibility at Deis is to sort of help define what the next generation of Deis is going to look like, and also what the next generation of Deis's ecosystem tools are going to look like. We are in the process of a major version shift from the 1x line of Deis to the 2x, and I like to call this the Great Kubernetes Rebase, because essentially what we're doing is rebuilding our platform on top of Kubernetes. So this is not a commercial for Deis, but I'm going to give you a little bit of introductory material right here up front so that it can kind of frame out for you all of the crazy things that have happened to us in the last year and a half. So here's kind of our guiding set of philosophical principles. The first one is that microservices are kind of hot right now, right? This sort of component architecture inside of the cloud has gained a lot of traction. It started really with places like Netflix telling us how they did it. But it's a good model. And I've used it at several places in the past and been really thrilled with the way it's worked. Containers seem to be kind of the ideal vehicle for building these kinds of microservices. They help you kind of constrain your way of thinking so that you start thinking in a microservices-oriented architecture. And then the final thing that we value quite a bit is, and I mentioned this yesterday in my 2 minutes, right? We are trying to build tools that help avoid the thrown over the wall problem, where you have application developers who are working on their applications, and at some point they go, it works on my laptop, and they throw it over the wall, and the DevOps guys on the other hand catch it and go, this is not going to work in our production environment. So Heroku, tried to tackle this problem, and we originally felt that Heroku did do a very good job on figuring out some of this, easing the developer workflow. And Deis version 1 was largely based on the idea that we should be able to provide the kind of application developer experience that Heroku did, but in a way that gave DevOps and operations the ability to deploy onto whatever platform they actually wanted to, whether it was AWS or bare metal inside their firewall or whatever. We also bought in fairly early to the idea that Docker was the way to do things. And so with Deis v1, we tried to do Docker to the max. That was sort of the principle, right? As many things as we could put into Docker containers and run them, we did. So not only were we running the applications that you deploy into Deis as Docker containers, but we were running the components of Deis inside of Docker containers. At one time or another, I think we tried every single one. Right now, etcd and Fleet both live outside of it, and everything else lives inside of various containers. We also went the Go route. I think that the original version of Deis was more Ruby-ish, because I think it was largely used Chef for the orchestration layer, but sort of outgrew that and did some Python, and then really settled in on Go as the language of choice. So most of Deis version 1 is in Go. We were looking for flexibility for DevOps so that you could deploy on whatever platform you wanted. But one thing we decided to sort of punt on was something Cloud Foundry decided they wanted to work on. And that was services. That was providing like a database inside of the cluster that the applications could wire themselves up to, or a key value storage or something like that. And we sort of opted for the bring your own services kind of mentality, and we focused more on the flexibility of the platform. And that the whole platform ended up being a big success. As we all know, the new hotness is only the new hotness for the length of time it takes for Miley Cyrus to put out an album, right? And then you've got to go on to something else. And what's really exciting about this space is that Docker was sort of the first part of what we think is going to be a major wave, and we think that we're still going way up the innovation curve on this wave, and there's a lot still to come. And the tooling that's surrounding containerized environments is getting really robust, really interesting, and I'm really excited about it. And so we switched focuses from V1 to V2, from doing sort of Heroku better to what if we turned the PaaS into a series of microservices that people could choose to run individual microservices if they wanted, or we would provide sort of the official assemblage of services you would need in order to run the full-out Deis PaaS. So basically we were talking about breaking things out and then making each little component inside of Deis far more robust. And we decided that where we went Docker to the max the first time, we're going to keep all the Docker stuff, but we're going to go Kubernetes to the max this second time. So we bought into that. We are working very hard on that stuff. We'll talk about it a little bit. Still, we evaluated our choice of Go, decided we made the right decision. We're carrying on with that. We're even trying to replace some of the few things that weren't Go with Go. Even some of our shell script we are now replacing with Go. And we're taking this sort of building blocks mentality. We are about, I'm optimistic, right? We're about 40% of the way into this. So a lot of the things that I'm going to talk about today are sort of lessons we learned from the early days of Deis on through, some of this stuff is like 2 weeks old, right? We're still learning things the hard way, the wrong way, whichever way. So I'm going to do sort of, David Letterman-y style top 10 list of things that we learned the hard way. Number 10, say yes to object storage, and you should probably say no to network file systems. I think I'm going to actually offend both Flocker and Docker at the same conference. So this here you've got a black cat in the black basket, white cat, and that's object storage. You can't stream a cat into a basket. The cat's either in the basket or not in the basket, right? Unless it's Schrodinger's cat. This is one of the things we really struggle with is we made the mistake in assuming that part of a successful platform, part of a successful PaaS-like platform, was to provide a file system storage system that everybody could use. And so we used Ceph. We got going into Ceph very deeply. We did a lot of very difficult engineering to get Ceph working. And then we found out, sort of to our dismay, that lots of people went, well, I don't really want to use Ceph. I'd rather use elastic block storage, or I'd rather use Gluster, or I'd rather, and we're going, but wait, we put all this work into it. When we stepped back and looked at it, we had put the work in, partially for ourselves and partially for the people that deployed it, but we realized that we were sort of not really using it the way it should be used anyway. Largely, we just had chunks of data, backups, log blobs, stuff like that, that we needed somewhere to store. And we had bitten off this huge chunk, which is Ceph, to try and get it to work in our various cloud environments, and it was tedious and difficult. When we had the meeting where we went, what are we really using? We realized that object storage is a better model. We've got an object, we just need to put it somewhere and get some kind of handle back to it when we need it later on. So why, sort of what are the key differences here and what made us choose one way or over another? A big one is that object storage was largely defined by one company, Amazon, defined the S3 API, right? Easy to use, REST-y kind of API. But everybody picked it up. Swift is S3 compatible, React CS is S3 compatible, Minio is S3 compatible, Ceph is S3 compatible, and we went, wait a minute, so we would have one API to use for all of our object storage kinds of needs, or we could go the block storage route where everything is sort of roughly POSIX-y, but some of them will allow multi-reads and multi-writes, some of them will allow only one writing host and all reading hosts, some of them require only, and rather than deal with the headache that is the sort of plethora of different implementations, we went, well, let's stick with the single S3 sort of model where we know exactly what we're working with and where we can plug in a whole bunch of different backends and assume that we're getting almost identical behaviors between them. All right, lesson number 9. Turtles all the way down, or the strange things that we do in the name of security. So part of one of the features of Deis 1 was that we provided Heroku-style build commands. So you push your source code up, it gets compiled somewhere on one of our servers, it gets bundled with a Docker file, compiled into a container, pushed into a registry, and then deployed out as a Docker container in your Deis cluster. The problem for us is that the code that gets pushed in is essentially untrusted code. So we wanted to come up with a solution. So just to step back and take a quick look at Docker security, there is a fairly well-known, fairly well-understood set of security concerns around running Docker, right? We all kind of know these. You're sharing a kernel, you got C groups and things like that. We kind of understand that space. But we were worried more about the fact that we are actually building containers inside of containers. And there are certain amounts of privileges you have to give the Docker system in order to be able to build a container. And we got to the point where we started to worry about how safe it really was to allow people to upload untrusted code. Not even because they were malicious. Most of the deployments of Deis, the code is vetted well before it's ever pushed into Deis by the group that's maintaining it. But accidents could take down substantial portions of the cluster. And so security sort of became a fairly big deal to us as we started architecting V2. So we're sitting around one day. We got this crazy, crazy idea. What if we ran Docker inside of a VM, inside of a container? Or really what it was more like is, what if we started with Kubernetes, which runs Docker, put a Docker container in there. That Docker container has QEMU, which is an emulator, and that inside of that has another Docker running, which inside of that has its own container that's running as a build engine. If you're not getting dizzy, you're doing better off than I was when we first came up with this idea. And the idea was simply this. Right here at the VM layer, we can get a certain level of resource isolation that makes the Docker engine perfectly happy because it believes it owns the operating system. But between here and here, there's a kind of boundary that prevents a security escalation, a simple security escalation from breaking you all the way out and causing havoc on the rest of the system. So it seemed like a good idea and seemed like a bad idea at the same time. And here's what we discovered, really to our shock. We wanted to run in full emulation mode rather than use KVM or something that would leverage system resources, because a lot of cloud providers will not allow you to do that. And so we wanted to make this so that you could deploy it into Amazon or DigitalOcean or Azure and not have to worry about what the particular VM constraints were. We figured this was going to add major overhead to build time. We were actually shocked to discover that it added a little, just a shade under 10% to the build time. And we're going, hey, when it comes to build time, I will gladly take 10% for the security isolation. Then it came to moving the built image off of the VM. That took us 40 minutes instead of 2. And we went, that is not good. So we are still in the middle of this experiment. We are trying to figure out if we can achieve this kind of security model without forcing the customer, or the application developer, to wait 40 minutes to get their image back off of it. I'll keep you updated if we solve this problem. I know that the Rancher has also gone down this path. I know they have a GitHub project out there. And we looked at it a little bit a few weeks back, and I'd like to look at it again and see, but I believe they're using KVM for it. All right, lesson number 8, the cluster bomb. HA clustering is kind of hard, and it gets harder the more moving pieces you have in your network. And etcd has, for us, been the tool that has ended up being the case study in how to run good clusters. Incidentally, before anybody thinks that I'm picking on etcd, a couple weeks ago I was at HashiConf and listened to another guy give basically the same kind of talk about his trouble with console. And most of the things he had issues with there are the same kinds of things I had with etcd. The problem is, you put these things in, and they become sort of a central component of the way you're orchestrating stuff, the way you're lining up your logistics inside of your cluster. And when they tip over, bad things happen. So we used etcd in sort of a naive way. We just kind of walked through the tutorial, figured out how it was working, used the discovery service, figured that it could do a lot of the self-healing stuff on its own, and pushed it in. And that was sort of our first go at it. And over the last year or so, we have been learning lesson after lesson about how to really run etcd. And we would spend time. Here's an example. I could actually talk about this one for a really long time because we've done a lot of weird engineering stuff around this. But for example, we'd have a cluster of, say, 3 etcd nodes. As long as you've got 3, and your voting algorithm works, and you have a suitable leader election, and something can keep writing, right? Your write operations and your read operations will still work. You lose 1, you're down to 2. They can't elect one of them as the leader, and so they kind of lock up. And they wait around until you bring up a 3rd one. Well, if the first one dies, it's still registered as one of the 3 peers. And when you bring up another one, it won't register as a new peer. It'll say, oh, there's already 3 peers. I'm going to nominate myself as a proxy. And so then it won't reach consensus again, but you'll have 3 running etcd nodes and they still won't be doing anything. And if you start up a 4th one, you'll end up in the same case, because it still thinks it's got a cluster of 3 even though 1 is offline. And so over the course of examining how this works, we've had to figure out ways of actually writing code that intervenes in that system and says, wait, is this node actually there or is it gone now? With Kubernetes, this has actually turned out to be fairly easy. We query the Kubernetes system and say, hey, the etcd cluster thinks that it has these 3 pods. Do you have 3 pods named this? And Kubernetes says, no, this one's not here anymore. And then we go back to etcd and we remove it out. And then the next time we start one up, then it joins us up here and it resolves it. The bottom line, before I go on way too long about this, is that we discovered that with any of these clustering solutions, this is a place where you want to spend your time. And so we learned some hard lessons with etcd. We immediately went on and started working on Postgres in a sort of flexible master minion sort of mode, where the traditional Postgres, you stand up a master and you stand up a bunch of minions and the master replicates data out to the minions, and the minions become basically read-only. And you can set it up a wide variety of ways, but we wanted to get it to the point where if the master fell over, one of the minions would get elected as a new master. This is not something that we found out a way to do natively in Postgres, though I wouldn't be surprised if somebody had cracked it. We ended up with a tool called Governor that used etcd to sort of track the state of various Postgres instances and help us achieve that kind of thing. Now we're on, so we've got that's out there in Deis/Postgres. Now we're working on React and we're working on Minio as well. So we've realized that really one thing we can add and really do a good job of is figuring out how to run stable service clusters inside of the sort of volatile environment that you get when you're running a containerized infrastructure. All right, lesson number 7. Docker is a whale on the move. We made a mistake, and our mistake was to commit that we were going to stay at the very tip of the Docker release cycle. So when Docker 1.5 came out, we'd switch right away to 1.5. When 1.6 came out, we'd switch right away to 1.6. And now we use Docker for a whole bunch of stuff, right? We're doing builds with it. We're deploying containers with it. We run our own registry inside of Deis. A lot of the stuff that Nick talked about, we run fairly similar architectures in the Deis cluster that they run in their CI/CD system. But here's what we discovered. Every time we'd move to a new release, something surprising would happen. Something surprising would break, because Docker doesn't really do semver the way we expected them to. So when 1.5 goes to 1.6, the sort of semantic versioning scheme would indicate that it would be backward compatible, right? They wouldn't have broken anything or removed anything that was already there, or substantially changed something that was already there. Every single release, we found at least one surprise that has caused us to sort of go back and rework sometimes fairly major portions of our code. The 1.11 release of Deis, the brunt of our time doing development was to switch pieces of the infrastructure so that we could upgrade to Docker 1.8. And we've kind of backed off at this point and said, all right, is it worth staying right at the very edge in order to, to encourage people, yeah, we're always up to date on Docker? Or is it worth to hang back a little bit and sort of ride the back of that wave? And we've opted more for doing that, because when you use Docker that deeply, it feels safer to do it that way. And I understand why Docker is moving as fast as they are. It just ends up being frustrating for people like us who are trying to do fairly deep integrations with it and stay right on the cutting edge. Keeping with that nautical theme, lesson number 6 was to sink the Titanic while it's still in the harbor. Everybody's happier when they're not on the boat when it sinks. Testing is a very, very important part of what we do at Deis. We have a lot of people who are very passionate about the way that we do testing. I really can't say that our mistake was under-testing things, because we have worked very hard all along to test. But the platform increasingly gets more and more complex. Remember at the beginning I said what we really wanted to be able to provide was a way for those who deploy it, the DevOps group who's working with it, we wanted to provide them a way of saying, you know what, I don't want Ceph, I want Elastic Beanstalk. I don't want to send my logs here, I want to send my logs here. I don't want, or I don't want any persistent storage anywhere on my cluster. We have actually done a number of installs that do that. So all these different components have to be very flexible, right? Because when you're not storing anything, you have to be very aware of what your current running state is. Whereas if you're storing stuff, you can get kind of lazy and push stuff out there. And the more flexibility we've tried to give to those who are deploying Deis, the more complexity we're having to introduce into our own platform, which means the harder it has become to write tests. So we're kind of in this state of continually experimenting with different ways of testing. Kubernetes is going to be an exciting one because we have a different method of being able to push things into an environment, seed the environment with certain information, run some tests on it, and then wipe the environment out in a very clean and reusable way. And so we're kind of excited to see what we can do there. But in the meantime, we use Travis, we use Jenkins, we have unit tests, we have functional tests, we have acceptance tests, and we still actually do a pretty hefty dose of manual testing, just because the human error component when you're setting up a system this big is actually very revealing. You find some things that you just would not have thought were in there. Ideally, we'd like to get away from human testing all the way because it takes up time. But it's something that those who are more passionate about testing than I am have pointed out time and time again. You know, we are gaining valuable insight from doing it this way. And until we're gaining that level of insight with other things, it is actually useful for us to collectively get together, spend a day spinning stuff up and tearing it down. So right now, the way we do it is all the other automated testing happens with just about every single commit, every push that we do into our GitHub repository. But a couple days before the release, between code freeze and production release, we'll take a day or 2 days and say, all right, here's a big spreadsheet of all the different setups we want to test, and just go sign up for the ones you want to do. So a couple people will do DigitalOcean, a couple people will do Azure, a couple people will do AWS, and you just do some test setups, run a couple of sample apps, and see what happens. And inevitably, every single time we've done that, in spite of the fact that we have tons of automated tests, we have still found at least 1 or 2 bugs that our customers would have found otherwise. So, you know, so far, in spite of the old school nature of it, it has turned out to be a useful testing technique. Right, we're about halfway through the top 10 list here. Gophers are awesome-ish. How many of you have used Go before? Yeah, we like Go a lot, and there are actually 5 things that I really, really love about working with Go on this particular kind of technology. One is that Go has some really great tooling. I remember picking up Java and going, so I need the JDK, I need this build tool, I need this testing framework, I need this, I need this, I need this, just to build sort of simple applications. And the Go developers put a lot of thought and effort into building a core tool chain that is very flexible and provides for the vast majority of your needs. So you've got, of course, things like a compiler, and a documentation generator, a formatting tool, a race detection tool. You know, the list sort of goes on, and you end up with this kind of robust set of tools. There's even one that I love to play around with that will allow you to sort of write a regular expression-y sort of thing on the command line and refactor your code. And because it's syntax aware, it can do very clever things that your regular greps and awks and seds do not do very well. So it's a good tool chain. It's a really strong tool chain, and that makes my life as a developer much easier. Number 2, and Nick had talked about this in the last one, you can compile Go down to binary. You can compile it down to a static binary that doesn't dynamically load anything, which is a fantastic fit for containers. We had too experimented with Scratch containers. We ended up with Alpine-based containers. So most of the Deis components run in Alpine 3.1 or 3.2. So they have little tiny Linux images, and then usually a Go binary and occasionally some shell scripts to help it bootstrap. Again, we're trying to move away from shell scripts and just go with Go. But it's a static binary. And so altogether, on a good day, we have sub 25 meg images, and that's small Go binaries running on a very small minimal Linux guest. Go has a lot of rich libraries, and the ecosystem is growing very rapidly, and we've found some very, very high quality third-party libraries. We use a lot of them. We use actually about 70 of them. Go is also fairly easy to learn. People on our team have come from Ruby background, Node.js background, Java, Python, Clojure. And all of these people have this is their first or one of their very first Go projects. And I like to observe and see how quickly various people pick it up. And because the syntax is fairly simple, they tend to pick it up. Not all of them like it. The Clojure developer in particular would prefer to be writing Clojure. I can't argue because I can't write Clojure. But it does seem to be an easier language to pick up and learn and do. And for us, it is cross-platform in the sense that we need it to be cross-platform. Many of us work on OS 10 for our day-to-day lives, and you can write your Go code in there. And with reasonable accuracy, if it'll compile and run on OS 10, it'll compile and run on Linux, which is our target. There were a few very rare exceptions, and each subsequent Go release seems to fix some of those. There used to be issues with resolvers and things like that, but largely we've had this experience that if we can run it on OS 10, we can run it on Linux. But we might have been just a little bit too starry-eyed about Go. In fact, you're probably going, wow, this guy's a total Go fanboy. And there are some issues with Go. And ultimately, we decided it's not worth switching off of Go. We like all of those advantages so much, there's no way we're going to consider moving off of it. But there are a few things that just drive me crazy about Go. One of them is, this came from the Clojure developer. He says, look, you told me Go was easy. All you really meant was that Go has a really simple syntax, because I'm writing a lot of code to do fairly repetitive things. And it's true, there are certain things in Go where, because of the construction of the language, there is no compact way of doing it. The error handling method is great because it encourages you to the maximum extent to deal with the error in the context that the error occurs, or to willfully punt that error back up. But there are some cases where it's like, oh, I'm writing yet another little if block to capture this error. It would be nicer if I could just declare my intent and have it take care of what I'm doing for me. That actually is the Clojure developer's biggest pet peeve with Go. Like, can't it just throw something? I just want it to throw something. I thought he was going to throw something. Now, the next problem is package management, followed closely by package management and also package management. We had a really rough discovery a couple of days ago, and that was that GoDeps was essentially hiding the fact from us that we had 4 different versions of the exact same package being pulled in. And we don't know which one ended up getting pulled in finally. It was probably the first one that it found. But we don't know what the ramifications of that are. Because if 4 different libraries said they needed this thing, but they pinned it to a particular version, the only way for us to figure out which version is the version is to go back manually through the Git history of each of those and see what's changed, and then look at all the source code that calls it and figure out if there's something in there that's actually important, or that it just happened to be the version that got pinned when somebody ran GoDeps. And we've, there are other issues we've run into where packages like Kubernetes Kubernetes has around 100 dependencies. I think it really fluctuates depending on various, in fact, depending on the commit. But that's a lot. We have 70. So it's not quite 170 because we share some in common, but that's a lot of dependencies to manage. And when you discover you can't really trust the dependency resolution of your system, you start going, wait, are we building a time bomb, or can we safely ignore this? Do we just ignore it until something blows up? Or do we try and build some tooling? I've been working on another package manager for Go called Glide, and have been trying to solve this problem, and it is hard. It is a very difficult problem to solve. And I've done it at least 3 wrong ways. So, but it is a big challenge for us, and it is, I would say, really the #1 issue we've had with Go. Those of you who complain about Go not having generics, you will find no sympathy in me. I just don't care. But that is another one that you'll hear frequently from. Okay, where's this one going, right? Your team is like your underpants. Anybody want to guess? No, please don't guess. They can really only stretch so far. Now, I'm not going to lecture on management because I'm not qualified for that. But I will talk about microservices. Does anybody recognize this picture?
Ready Player One?
Ready Player One, that's right. In the book Ready Player One, the main character grows up in this thing called the stacks, am I right? Where essentially, they're like, it's a trailer park organized sort of vertically, right? And so you got an Airstream on top of, Winnebago, and they're just kind of stacked up. Some are new and shiny, some are old and crusty, but they're just compacted into this one large space. This, to me, is my mental image of microservices. You got a whole bunch of things. They're kind of repetitive in the sense that they all have the same kind of structure and everything like this. But each one's individual and unique, and some are beautiful and some are ugly, and some are about to tip over, and others are fairly robust. I really don't think you should stack something like that on top of something like that, but our biggest pain point in learning how to do microservices right has been a people problem. It has been this. I'm going to work on the etcd microservice. He's going to work on the Postgres one, and he's going to work on the Builder one. So now we've got 3 people working on 3 different microservices. Well, it's not really a good idea to have each of us working in isolation, but I'm too busy to help him, he's too busy to help me. How do you develop 12 microservices with a team of 8, or whatever your actual numbers are? And what worries us is that everyone will be working on their little set of services and believe that they're achieving the mission. And then we get to the Titanic part where we try and run our tests and things blow up. And one guy says, well, it's not my fault. I built it exactly the way that I described it to you. And the other guy says, well, it's not my fault. I mean, this is doing exactly what it's supposed to do. How do you accommodate that? Second issue, how do you accommodate the bus factor, right? If one of us leaves on vacation, does that mean that person's microservices get abandoned for a couple of weeks and the rest of us just cope with it? This is one of those rare cases where the best solution for us has been to introduce actual people process into it. If any of you have ever participated on Go's issue queue, either filing an issue or sending a PR or something like that, you will notice that we discuss things a lot and then we LGTM things. Looks good to me. We actually have little GitHub labels, LGTM1, LGTM2. The idea behind this is that we actually want to make sure that at least 2 other people have looked at every single line of code that goes into Deis, any of the microservices, anything like that. There are a few reasons for this. One is the obvious case where I'm often myopic and blind to my own dumb errors, right? And Kent and Kirthan and my colleagues who are sitting here are often better at noticing the errors I have in my code than I am, because I'm thinking in a very specific mindset while they're going, what does this do?
I just opened a new issue.
That's it, out you go. No. Wait, I meant that's a feature, not a bug. And so that's a really good dynamic to have. The other is that you ensure that everybody's seeing the code and picking it up as you go. And the third is that it keeps you all on the same page, because when I understand what he's doing and he understands what I'm doing, then there are fewer surprises when we get to that integration point and I say, all right, here's my piece, and he says, here's my piece. It has been tough with microservices to do this, and admittedly, I have argued against this on occasion, going, this is so frustrating. I cannot get 2 people to LGTM this for me. I can't even get 1 person to read the code for me. And mainly it has come down to the process of bribery. Chocolate, cookies, coffee, milkshakes. No, and expressing to other people in actual friendly human language, look, I really need somebody to take a look at this code. We have also sort of added some process and said, ideally everybody should spend X number of minutes each morning, I think it's 15 maybe, trying to go through the other issue queues and PR things. I'm worse about that than others, but I have one colleague, Matt Boersma, and actually Matt Fisher. There are a lot of Matts at Deis, both phenomenal at going through every morning and clearing through PRs. If it weren't for them, a lot of LGTMs wouldn't happen. And in consequence, they tend to know a whole lot about the big picture view of how Deis is working. Right, we are down to number 3. All your schedulers belong to us. Which could also be titled, Somebody Set Us Up the Bomb. So here was our idea with Deis version 1. If you didn't get the reference, I'm sorry, I'm old. In Deis version 1, we had this great idea. Look, we've discovered that people like different file system backends. We've discovered people like to do logging differently. We've discovered that the Heroku build pack thing is really popular because people pick different languages. Here's an idea. There's Fleet, there's Swarm, there's Nomad, there's Kubernetes, there's Mesos, Marathon. How about if we support them all? And so we kind of did. We actually worked to the point where we had preview releases. Fleet, of course, was the scheduling tool we used for Deis v1 when we started it. We added Swarm support. We added Mesos support. We added Kubernetes support. And then the pattern emerged. Support all of the schedulers really turned out to mean support the weakest scheduler. And not the weakest individual scheduler, but like the weakest parts of the sort of union of weakest pieces. So if one scheduler is excellent at handling volumes and another one is excellent at scheduling resources, you lose both of those because one's weak at scheduling resources and one's weak at managing volumes. So instead, you have to accommodate a weak volume managing, weak resource usage tracking scheduler. And the farther we got down this road, the more we went, well, this kind of sucks, because here we've got a really high-powered scheduler and a low-powered scheduler, and we're developing a sort of wrapper that makes it even weaker than those two. So we had a really tough couple of days where we said, all right, what are we going to do? We had just released the Kubernetes preview release. We were getting good feedback from that one. We were comparing it with feedback we had for the other schedulers. We were looking at what we thought had the most likelihood to succeed and met our current needs. And we got, first of all, narrowed it down to 2. We had Mesos, we had Kubernetes. Mesos's flexibility ruled it out because we realized we can always run Kubernetes inside of Mesos. And so we ended up picking Kubernetes as our scheduler. It did what we wanted, and we realized once we did that, we could really kind of dive deeply into Kubernetes and take advantage of its secrets management, its volumes management, its service discovery, and so on. And so that's what we did. That, incidentally, is the reason why, if any of you are wondering why Swarm and Mesos and stuff like that aren't getting updated, that's why. All right, this one I might have gone a little overboard. Mono repos are evil. Okay, mono repos aren't exactly evil, but they have some pros and they have some cons. The pros are that all the code's in one place. Everyone gets alerted on everything, and it simplifies the build process, the documentation project. There's only one issue queue. But the cons were, as the code got bigger and bigger and bigger, each individual developer had more and more and more things they had to be able to accommodate on their development workstation. And yeah, then there's the everyone gets alerted on everything. It's a good idea when you think of it in terms of keeping the team together. It's a bad idea when you realize you're getting notified about things you really don't care about at all. And then we had the problem where stable and preview features got mixed because everything got committed into the same repo. And then came the real sort of clencher for us. We realized that we were telling all of our app developers, develop microservices. And we were saying internally, we're going to develop microservices. But in order to get all of our microservices, you had to download this giant, massive repository. So even if you only wanted one small slice of the pie, you had to download the entire pie, get all the dependencies, get it all up and running, and then pick the things you wanted. Ultimately, what it came down to was we could not justify, as an open source platform that had made big promises to be friendly and good open source, we couldn't justify the fact that we were then burdening our users with the idea that they had to sort of buy into our mono repo philosophy, even if they just wanted a piece here or a piece there. So while we thought one repo with everything in it was a good idea, hey, Google does it, we realized, and it was a tough realization, that we needed to really start breaking down. So if you look at our GitHub account, you will notice that in the last couple of months, we have gone from only Deis/Deis to Deis Rigor, Deis etcd, Deis Postgres, Deis Ryak, all of these other projects. All right, we're up to the last one. Lesson number 1, and I alluded to this several times already. Kubernetes floats my boat, but it's a very big and complex boat. You see, we thought that we were simplifying things by picking just one scheduler. But then, of course, you have to sort of dive all the way into that one scheduler. And Kubernetes has its own vocabulary and its own conceptual framework, its own way of looking at things. There are sort of, you can sort of have Kubernetes bifocals, right? You can look at one layer and see the manifest with pods and replication controllers and services. Or you can, look down through the other side of the bifocals and see the kubelets and the kube proxies and the heapster and the C advisors and all of this kind of stuff. And it gives everybody, it's sort of like a jarring experience the first time that they encounter this. And so in order to get all of the developers ramped up, we basically did it this way. The guys who worked on the initial preview release of Kubernetes began educating some of us about how Kubernetes worked. And then we started educating other people. We signed up for classes. We tried to pair up people who understood it with people who didn't. And one of the things that came out of this is there's a huge opportunity with Kubernetes. So there's Kubernetes, right? This is the line. Beneath the line is all of the servicey stuff in Kubernetes. There's the kubelet, there's the kube proxy, there's all the orchestration layer that's going on underneath the hood. Now, this is great, it's fascinating stuff, but we don't really need to deal with that space unless something's wrong. Most of the time, what we're interested in are the things that we're putting on top of Kubernetes that we're deploying out into the world. And there's a separate set of concepts for those. There are pods and services and replication controllers. If you've heard Kelsey Hightower talk about this, he's got some excellent presentations that are all available online. There's not a lot of tooling. There's a lot of tooling for dealing with this part. There's not a lot of tooling for dealing with this part. And so ultimately, en route to building Deis v2, we realized, well, there's an opportunity to sort of contribute into the Kubernetes space by building some useful tools. And so over the last week, we have started talking a little bit about this tool called Helm, where our idea was, assuming you've got a Kubernetes cluster running somewhere, we wanted to streamline that process where you had to copy and paste manifests down from the Kubernetes website and try and edit them, tinker around with them, try them, see if they work, bring them back down, try them, tweak them a little bit. We wanted to make it feel like homebrew, where you type in a command and it installs it in there, and you're pretty sure that when you type brew install whatever, you're going to get a working application. We wanted to do that with Kubernetes, so we wrote a tool called Helm. Kubernetes, by the way, means captain, and Helm is, the steering wheel. We thought we were clever. So assume you want a Redis cluster, right? The idea was we wanted to provide a tool where you type in Helm install Redis cluster, and it spins up a Redis cluster into Kubernetes. Now, if you want to tweak it, we copy all those files locally. You can tweak the files and then reinstall it and be up and running with a Redis cluster. You don't have to go through that process of running the first pass through, picking an image, and trying to write all the manifests and build the services and do all of that. That's done by the community and tested for you, just like any package management solution. And it gets you, sometimes it'll get you 100% of the way there. We're shooting for something like 80, where we get it to the point where all you need to do is go in and customize it. So that's what I really wanted to talk about today. We've learned some tough lessons. We feel like we've stayed pretty true to the guiding philosophy that we set out with, right? That containers are ideal for microservices, and that we can use that to sort of start getting over the throwing it over the wall. But along the way, we've learned a lot of stuff about good ways to cluster, good ways to tool, good ways to test. And the bottom line for us is we think that even though the new hotness today is a little different from the new hotness from yesterday, we're on the right trajectory, heading up a wave that has yet to crest, and we've got some really cool technologies that we can play with. All right, thank you guys very much. I don't know if I have any time for questions. Do I have a minute or two?
Yeah.
All right.
Precisely.
Yep.
Quick testing related question. How do you feel about regression testing, and do you guys cover that at all in Days?
How do we feel about regression testing, Ken?
I don't have an answer.
We do, at unit levels, we do some regression testing. Oftentimes, those kinds of cases become part of our functional testing suite, but that is one of the areas we have not done a good job of formalizing. And one of the things we're battling, and Nick and I had this long talk about this yesterday, you want the most robust testing system you can build without having to do a lot of work. And it's that last part that's a pain.
Doing that, I work for Hertz, and I'm trying to accomplish that as well.
Yeah.
There's no one size fits all.
Yeah, if anybody finds a silver bullet for that problem, I will pay you a lot of money. Yeah?
So since you guys converged on Kubernetes, I'm curious if you guys are using its DNS service discovery add-on, and also did you guys come away with any lessons with respect to service discovery routes?
Yeah, actually, that's a great question. So the question was what we learned about service discovery from Kubernetes. There are two ways to do service discovery in Kubernetes. One of them is through DNS. The other one is through environment variables. So when you declare a service in Kubernetes, it will automatically notify the DNS server, hey, there's a service running at this host on this port, and it has these names, right? So you can say there's this port named HTTP is actually listening on 8080 on host 10.2177.2. And the DNS resolver will handle that for you. So then your app just has to go, hey, give me the service named this listening on HTTP, on the port named HTTP. The other route they provide is through environment variables. Here's what we've sort of come away with. We want to be able to deploy on the maximum number of Kubernetes clusters we can. Not everybody chooses to enable SkyDNS. So we have been, to the greatest extent possible, we've been using environment variables for setup. The downside is they're static. Once the pod comes up, those environment variables don't change. So in other cases, we've gone with the DNS, we've started looking at the DNS, and we've started looking at whether it just makes more sense to run etcd in cluster. Right now we're kind of on a case by case trying to figure out what the best practice is there, but that's what we've come up with. Here's your tile.
I guess we gotta wrap up.
All right, well, thank you guys very much. Have a good day.
No, well, it was more of the connection here.
Cool. Well, it is a Microsoft Office.
It is, yes.
I got a tile for you to give away. Give it to anyone you like here.
Okay, what's the
The tile is like a little Bluetooth tracker. You can put it in your backpack. You can find your backpack later. If you lose it, you push the button. That's going crazy. If you lost it far away, then you can push the button, and everybody from the tile app, it will crowdsource the thing, and it will tell you where it is, like geographically. So you can look at the map and like, oh, okay, I left it with my friend Paul. You go to Paul, you push the button, and starts yelling again.
All right. Cool.
Oh, this is so horrible. Okay, so you can start any time now. This is all your time now.
Okay.
At this point.
That's it.
And then we're going after this. We're going to lunch. Yes. Yes, we are.
Is that working? It's working.
Yeah, you can use. Also, you can use this if you want to walk around.
Oh, okay.
This might be easy because you just attach it somewhere.
Assuming this works. If this doesn't work, then I'm just going to. Oh yeah, the 5F. Same? Alright, cool. Alright, that doesn't seem to be working, so that's fine. I'll just use this.
Alright.
Okay. Alright. Hello everyone. Two more people.
I'll go send these more people in.
security researcher, software engineer, hacker, tinkerer, formerly of Docker, which was originally on the prospectus. Free agent now. Enjoying my time off, giving some talks, working on some new projects. I'm going to be talking about patterns for, well, what was patterns for secure containerized applications. And then while writing the talk, I realized, well, you know, really, we're talking about applications. We're not talking about containerized applications, because if you're writing secure applications, you're using containers. I mean, that's obvious. And second, why would you not write secure applications, right? So you're writing applications. You know, they should be secure and they should be containerized. I shouldn't have to say it. So I just struck those out. I guess they're still technically in the title. So I'm going to call these 3 patterns. And these are not necessarily all secure patterns, they're patterns. A pattern of isolation, where you have services that are running on different hosts. And those applications, right, those services are completely isolated from each other, except perhaps from the network, but from a compute perspective, they are isolated. We have consolidation, where we can take that isolated application and throw it inside of another host and run those as VMs, right? And finally, we have what I'm calling fragmentation. And fragmentation, while not always a pretty word, is actually not a bad thing here. It just means that we're going to break up and isolate things a little more. So I'll talk first about this pattern of isolation. So we have a basic high-level application with a SQL database of some sort, a message queue of some sort of back-end web service running an API, and the front end. Now, each of these might contain multiple services and components. We're going to simplify it and just presume that each of these is just one basic application. So, you know, we're going to take load balancers out of the picture. We're going to just assume that the front end is just, let's say, an Nginx or Apache server or something. So the whole thing is our application, and front end is our service. And in the isolation pattern, we just take that front end and we're going to say, we're going to put it in its own host. Maybe we'll put it in its own VM, and maybe we'll put it in its own container. And those are separate from that container, that VM, or that bare metal machine. Possibly all 3 of those, you know, nested like this, are isolating that front end from the SQL Server, the back end, and the message queue. Right? And our host, our application, looks at a high level something like this. You know, your host and your VM and your container are all just the same thing. They're running all of these different applications, which I picked some of them were kind of bad, like SendMail, right? You know, you're running these all together on a host in an operating system, right? And what I'm going to propose here is, well, why are you running SendMail and Apache and your monitoring agent all together on your operating system, where they can see each other, they can touch each other, they can harm each other, right? So this pattern of isolation, this first pattern, has us having a separation of these services, but these processes are not isolated. So pattern number 2 is consolidation. And this is not actually a security pattern, but this is a pattern that I have seen a lot in our industry. And I mean, mostly it's a cost-saving measure, right? We are trying to consolidate our resources, save save power, save capital expenditures, and we want to say, well, we're going to use VMs, and we're going to eliminate this CapEx. We're going to run fewer machines with more services and we're just going to, hypervisors are going to provide our isolation. Right? So you have this, right? You take your isolation pattern that we had before, and we literally throw it in a box, and then we make the boxes inside of instead of machines, they're now VMs. And on the outside, well, now we have a real host, and we're still using isolation patterns, so we're good, right? We're isolated. These applications are secure because the isolation pattern that we were using before was secure, right? Running each of our servers on a different host was secure. So we'll just run them as VMs, and that'll be secure because, it's the same pattern, and hypervisors are certainly fine. All right? So containers come around, and we do the same thing. And we say, well, we're going to replace our VMs with containers, and that's going to be great. We're going to get even better better consolidation. We're going to get more performance. We're going to have more resources. We're going to have more cost savings. And we just replace VM with the word container, and that's probably fine, right? We're consolidating. However, the problem with this is that this was never a security model. That this was a consolidation model. This was something that was saving us money, and does save us money, right? This saves us even more money than the VMs. And that might be okay for you, right? If this is what you want, if you're trying to save money at all costs, then this is perfectly fine, right? You're going to save capital expense on this, but you are paying technical debt in your security, which if security matters to you, is not necessarily what you want here. There are use cases where this is very viable. There are people doing high frequency trading where they said, well, we couldn't use VMs. We had to use bare metal machines. But now with containers, we get high performance, and we get better isolation than we could have before, right? So it's actually a net gain for them because the other model never worked anyway. Right? People say that, well, containers aren't secure because I replaced all my VMs with containers and they are just not as secure. And it drives me crazy, right? Because you're doing it wrong, right? If this is the model you're doing it wrong if you're doing it and thinking it's providing you security. And arguably, you were already doing it wrong when you're using VMs, right? Because VMs do not, actually that's in a couple slides. So first I want to give you a little case study. The Zen project has had 38 CVEs in the past 12 months, as of 2 days ago, anyway. 29 of those had a CVSS score of over 4, right? These are CVEs. Now, it all depends on how you rate CVSS numbers, and they're not all created equal. Sometimes they are overblown, sometimes they are underblown. But I'm going to assume that out of those 29 CVEs, that at least half of them can allow a breakout from your hypervisor or from your VM, right? That's serious. That is not really very secure, right? That's not isolation. That is not the same as running a physical bare metal, right? And it's important to note because, this is Zen. And you can say, well, VMware is better or KVM is better. There are so many fewer CVEs. Well, first of all, the absence of CVEs does not mean the absence of vulnerabilities, right? It may indicate a lack of response to vulnerabilities or a lack of transparency in the resolution of vulnerabilities, right? When a virtualization vendor releases an update, you don't know whether or not they actually fix vulnerabilities in it. You don't know whether or not the KVM team perhaps may just not be signifying that vulnerabilities are important. Many of those vulnerabilities get reported as QEMU vulnerabilities, not KVM vulnerabilities. They get reported as kernel vulnerabilities. But meanwhile, all of these things are actually affecting you, and you're just not aware of them. The Zen team is actually a really great functioning team, which is why there are so many vulnerabilities, or CVEs, because they're actually seeking these vulnerabilities, they're finding these vulnerabilities, they're letting you know about these vulnerabilities, which is why there's so many CVEs. Not that Zen is necessarily less secure. I would argue that it probably is more secure because of this. Although the most recent vulnerability was particularly bad. There was a vulnerability released yesterday, actually, which, well, announced yesterday, where it completely invalidates, I believe, the paravirtualization model in Zen, which is not very good. There was a patch, but it's shaken a lot of confidence, I think, in some of the community amongst Zen users. But I would also argue that that may not be, again, limited to Zen, right? That might be just the fact that we're coming to terms with virtualization is not a panacea. It does not solve all of our problems. It does not provide the isolation that we've been guaranteed for all these years. Right? And worse, x86, right, is considered harmful. And I've been actually saying this for some time, but there was a blog post a couple days ago and a PDF attached where they go through a lot of the vulnerabilities that x86 itself has had over the last few years, some of the research that's being performed into these vulnerabilities. And what we're learning is that x86 is an old platform that has had a lot of things added to it over the years and actually is vulnerable to quite a number of attacks. So even if your hypervisor is secure, we're learning now that you can actually use, just do things on the CPU directly. There are side channel attacks that you can perform. There are ways of potentially executing code inside of the CPU at low levels that are underneath of your operating system, right? And you can do that from inside of VM and inside of a container, right? Now there are some things that we can do with virtualization and containers potentially to try and resolve this. But the fact is that VMs do not contain. They're not protecting us from these attacks. And we shouldn't expect them to. So consolidation may be appropriate for you, but it is not a security pattern, right? Use it if you want to, use it if you need to, but don't presume that throwing things in VMs is going to solve a security problem. And equally, don't assume that throwing everything on a bunch of containers that do different things on one host is going to solve your security problems either, right? They're both consolidation. They don't solve the security. So pattern number 3 is fragmentation, also known as isolation. So this is actually really the first pattern, but it's a viewpoint on the pattern that we haven't really been able to explore before containers. Right? So we're going to take this isolation model on the left, which I presented earlier, and we're going to say, well, we're going to not consolidate, we're going to fragment. We are going to take the services that we're already running, and we're going to isolate them more, right? We're going to put more lines in the sand here. We're going to not just isolate the services on different hosts, we are going to isolate the different processes that are on those hosts, right? We're going to let the operating system do its job and try and provide some sort of security framework between those processes, right? And I don't know if this is what you consider microservices, which is literally just separating processes that are normally on host, but I do. And services are isolation with more seams, right? Not more services, right? We're not trying to create here more services for you to manage necessarily, right? It may look like that because you're managing more artifacts in a sense, right? Each of these containers might look like a new host, right, from your traditional management perspective, but it's really just processes. And you've been running these processes anyway. You're just going to wrap them in a container, and you've been managing 1,000 processes in the host before, and and now you might manage 1,000 containers on a host. So we're just putting more seams though, right? We're making those divisions between those processes harder, or more firm, right? And it looks, in a way, kind of like virtualization. Perhaps, which is why it gets compared to virtualization so much, but we get to, instead of separating these processes by virtual machines, right? We separate these on a single machine, and they get their own memory, their own disk, their own network, right? But they're containers, right? Like, this is the model that we've been looking at with virtualization for some time, but we get to do this with arbitrary processes on our machine and give them the benefits of, well, now we did just assess that, virtualization is not real isolation, right? And I would say that this is not real isolation either, right? But it's some isolation, right? It's quasi-isolation. We can tell these processes are going to get different sets of memory, different sets of disk, different sets of network. And if we want to wrap all this in VMs, fine, we can do that. It might protect our host from some of the attacks that are out there. But importantly, virtualization cannot separate these services, right? Running the New Relic server or the Sysdig server on your virtualization host doesn't give you visibility into your applications necessarily. Some of the products do have things where they can introspect VMs, great, as long as they understand the kernel on the host and the version of the kernel and everything else. But generally, those monitoring tools have to run inside of your VMs, right? Apache, right? If you're going to run a mail server, right, and send mails, again, a horrible example, but I put it there because it's a good example of something you don't running with, access to your Apache and your New Relic D and your rsyslog if it gets compromised. Rsyslog, right? You need to ship your log somewhere. You can throw collectd in here. You can throw any of these applications that you're going to run for operational purposes on your host and realize you can't run them on your virtualization machine. You can't run them outside of your host. They need to run with, in some way, right? Apache is the only one here that you actually need to have. All these other ones you need for operational purposes, yet because you need them for operational purposes, they're required. And you need to be able to separate them in the way that you separate VMs. And containers, to a limited degree, allows you to do that. All right? So we take kind of that model that we had before, which is here's our host with all these processes running together, and we just draw lines in the middle, and we make each of these different containers. Maybe not init. Init won't be a container necessarily, but it may spawn Docker, it might be systemd, and they can create these containers for us. OpenVZ, whatever. Right? So we look at a container like Apache, and we have a process list. And what's interesting about this process list is that, well, it's only HTTPD. It's not init. It's not all of these other things that might be able to compromise our HTTPD if it were compromised. And we also have here capabilities. And this is an important part of containers, which is that we can say this container does not have cap system in it, doesn't have sysmodule, it doesn't have DAC override. So if we run this, for instance, as a non-root user, this container may not be able to elevate the root. And if it did elevate the root, it wouldn't be able to override other users' files, only its own files. Right? So root can change its own files, like any user, but it can't change other users' files. It can't load kernel modules, but we're going to say, well, we're going to add net bind service and net raw, which says that this container can ping and can bind to port 80, right? So here's a container that potentially could be kind of everything but root, but still bind to port 80, which only root can normally do, right? And this is something that, by the way, virtual machines cannot do, right? So here's an example of your Apache server, right, or your front-end machine running on a VM or on just a bare metal machine. And you have your process list, which includes rsyslog, send mail, New Relic D, and your init server. but also it has all the capabilities. All of these processes can do all of the things. So if any of these processes were, for instance, running as root, or if, let's say, they had access to a binary that was set UID, such as sbin su, right? You have the su access, you have sudo access. They have a capability of elevating to root, right? Even if they're not run as root, they can become root because they have the capability to become root, right? Containers lets us take away abilities such as becoming root. In this traditional model, you are just, you always have the capability to become root, unless, of course, you create a container mechanism. So any of these processes, right, could elevate the root, could do anything to Apache that they wanted to, right? Well, well, damn, this seems like a lot of work. Right now, I have to manage all of these containers, right? I mean, I'm telling you, you're going to have all these containers. Now, granted, you have all the same processes anyway, but now it's a new artifact. It's a new container system, right? You need a lot of work. You need to build containers for these. You need to build Docker files. You need to have a whole system for managing this and deploying this. Except if you're using Chef or Puppet or Ansible or Salt, CF Engine, I don't care what you're using. If you're using any of these, you're already doing it, right? Each of these things, you already have, if you're using Chef, you're already making a Chef cookbook for rsyslog, but a cookbook for SendMail, and a cookbook for Apache, and a cookbook for New Relic D. You're making a cookbook for Sysdig. You're making a cookbook for whatever it is that you're running. You may not be running in a container right now, but you're running it out of a cookbook or a recipe or a manifest, or whatever your system calls it, a crumb. I don't know all the terms for all the different DevOps tools, but you're already building automation for these tools. So you just say, well, instead of building a cookbook for this necessarily, I'm going to build a Docker container for this, or I'm going to build an OpenVZ container or an LXC container. And that's really the crux there, right? It's not that hard. If you can build Chef cookbooks, you can build containers. And if you want to, you can build any of these, you can build containers using those tools. But you can take your existing tools, you can say, well, I need an rsyslog server, I already have a Chef cookbook for it. Okay, fine, use your Chef cookbook, build a container, and use that to deploy containers and not just processes on your host. Because this is going to isolate those processes from each other. And it's going to protect them from each other, right? And it does it deep down. It does it in a way that, so it does it in a way where VMs you couldn't, right? VMs were not granular. Hosts are not granular. You couldn't control what those processes in it were doing. This lets you dig the claws of isolation deeper. So I gave plenty of room for questions today.
So the capabilities you were talking about were basically the Linux kernel capabilities.
Yes.
In the list. I mean, obviously they could be something else, but that's where that was coming from.
Yeah, so those capabilities that I referred to are capabilities in the Linux kernel. Now, containers apply to other platforms, and they're going to call these other things. These happen to be POSIX capabilities, generally. So POSIX compatible systems may have them, but not all containerization systems actually necessarily care about capabilities. So like FreeBSD may care a little bit less, so like they have the jail system is not just capabilities, same as Solaris. Linux is a little bit more granular and kind of, we're going to provide the crumbs and you kind of piece together the cake yourself. Some of the other operating systems kind of provide containers as a more whole unit. By the way, for the first person to ask a question, which was you get a title. This lets you find things wherever they are. I don't know, it's like using Bluetooth or something. So, good. Let's say if you dropped it, you can still find it because it has a MAC address or something you can look up online.
Earlier you asserted that Apache running on a VM would be running as root. I've always run Apache as not the root user. So I'm thinking I'm not understanding
No, so I'm not saying it runs necessarily as root. Although Apache, for example, is usually spawned as root and then drops down to another user. That way it can bind to port 80. Also, some people use Apache so that it runs as root and then each of its sub-processes run as a different user. Right? So if you have a single Apache server, you can then have 5 different users and it manages processes for those users. And I'm not saying that you have to run Apache as root, right? I mean, you shouldn't run Apache as root. You should run it as a non-root user and put a reverse proxy in front of it, perhaps. But even if you run it as non-root, it still has access by default to setuid binary. So if there's a vulnerable setuid binary that's living in your file system, you can become root. If you're running in a container, you can say, well, setuid binaries just don't work. We refuse to let setuid binaries work, right? And that just removes a class of vulnerabilities. There are still other vulnerabilities, right? But we'll remove a class of vulnerabilities. And when we're working in security, there's no hammer that solves all problems, right? And we've treated VMs like a hammer for a long time. We need to be able to say, take away some of these vectors. Take away setuid. It's not even a vector anymore. It's gone. Any other questions? I know we're all hungry for lunch. It's all right. 3 more seconds? Nope. All right, thank you. You know what? No, I drew on the surface directly.
Oh, okay, your mic is on.
What's that?
Your mic is still on. So it was really fun to see you take on the whole hypervisor thing, because I just did the same thing last week.
Oh, you did?
I attacked it from the idea that KVM is 13,500,000 lines of code. Docker is 300,000 lines of code. And KVM has grown linearly over the last 10 years. They don't throw anything away. There were 6,500 commits per month in KVM this year.
Yeah.
There were 3,500 individual contributors to KVM this year. That sounds like an awful lot of hands in the pie.
Well, I mean, I'm not trying to make a VM versus container story. It's just everything. Like,
So why layer them on top of each other and accept the vulnerabilities?
Because the vectors are different.
Right. That's the main thing, is that the vectors are different. Right. We layer security because we solve different vectors. But VMs don't solve the problems that containers solve, and containers don't necessarily solve the problems that VMs solve. And worse, as I was trying to explain, people are using VMs, right, for not necessarily the right purposes if they think that it's giving them security.
Right. Exactly.
That reminds me of the talk of the Zen guy who said like such and such overall vulnerability in KVM, and then the guy from Godin started. I'm the head of security team at Google, and we're actively looking for bugs in KVM. And this is why there are so many vulnerabilities in KVM, not because it's buggy, just because we found them. This is what we're talking about.
Yeah. You mean just because somebody went looking at
Yeah,
it?
yeah.
Which was
It's
your
not
point.
necessarily a bad thing. That's a very good
Yeah, because
point
I mean,
that
like
you made.
there are users that assume that existence of CVEs
Is bad, yeah.
means that it's vulnerable.
There's all kinds of bugs. There they are.
Yeah.
Right. I mean, when I was at Docker, we had that problem too a little bit, where there's always there was concern from people in marketing. Well, wait, if we start telling people there are vulnerabilities, like they're going to think that it's vulnerable. It's like, well, if we're finding vulnerabilities, it means that it's not vulnerable.
Well, it's classic correlation is not causation.
Yeah. Well, I thought the best thing they ever did was like I forget who it was, they gave the talk where they talked about like containers don't contain.
Yes.
And they owned it at one point, and that really was a great talk, and it was the idea that like if you just put it out there, then people start to understand better the technology.
Right. Yeah, I mean, that was Dan Walsh, and the thing is Dan Walsh has, it comes from an SE Linux perspective, which is that SE Linux already provides a lot of this as a strong guarantee.
obviously VMs aren't the perfect security solution, but
oh, I don't know what our peak number is, but we have most of our services are running 3 to 5. There are a few that have some more. We don't have anything that's running even dozens of instances. Sure. We're using Postgres and Mongo and Elasticsearch, and we also have Zookeeper as a data store. It's used mostly for configuration management, but it's also a data store essentially. Our databases they're still monoliths. We started this 6 months ago, so all our services are talking to one database, or a couple of Mongo instances, or our Elasticsearch instance, and we're looking for something that will let us put those into containers. But as I said before, we're untangling our code, but we also have to untangle our data model. When we first made the venture into service-oriented architecture, a mistake we made was that we would one service would do some action, write something to a database, then another service would pick that up. So what you've done is you've made a non-local effect between two services. You've taken state and just sort of smeared it around everywhere, and that's something you want to make sure that you avoid, essentially, because then you have to tease that out, and that's very challenging.
Yeah, sometimes like you'll see certain diagrams about microservices, kind of almost appears that each microservice has its own database, but that's really not the way it turns out, right?
Yeah, I'd love to get there. One of the reasons we haven't done that is you can make a model for the data that your service might need, and you can sort of treat that whole database. You can take a piece of it and treat it like it belongs to that service. But then you have to attach particular databases to your slaves, and we haven't found a nice way to do that, to be able to just give a Docker container a database from our database server. We don't want to have to give all of the slaves all of the databases, and we don't want to make applications be able to put pressure on the Mesos infrastructure. We want to keep the infrastructure and the applications kind of separate. So if I heard about Flocker yesterday, and that may be able to just go and request a database, and that gets mounted in the Docker container. I hope that's how it works. I'll find out in the next couple of weeks.
You're using Qubit for discovery?
Yes. Qubit Bamboo is it's for writing HA proxy configs. What it does is it listens. So Marathon produces an event stream, and every time something happens, from a failover to unfortunately just changing a tag, Marathon will publish an event, and Qubit goes, "Oh, there's an event. I got to rewrite the HA proxy configs," and it does that, which is great because you can move things around, and they have a DNS name. So we have customer service at yoda.com, and that's where that service lives. And HA proxy takes care of all of that routing. So all Qubit does is listen for those events and make sure the HA proxy config is as it should be right now.
So you're not using Mesos DNS?
No, Mesos DNS it wasn't mature the day that we looked at it, so we went with Qubit. I don't know that I would recommend that as a choice if you were starting out today, but we got it to work. We invested in it, and it's functional. So I've heard good things about Mesos DNS. I can't say for sure that it does what you'll need, but it's worth looking into if you're starting out building a Mesos pass right now.
So in sort of the same vein as this database question, one thing that we struggle with is giving developers their own sort of, I would say containerized, not actual container, but their own essentially private database to be able to write code against without affecting staging or production clearly. So I'm curious, in your experience, given that you guys have sort of like a monolithic DB architecture, what you guys have done on that end for developers?
We have a dev database. So we have a 3 environments. We have dev, we have QA. We actually have a number of QA for various purposes, and then we have production. And so the day-to-day stuff the developers are using, they use the dev database. We have a sort of a clean schema that we apply every night. So if you've destroyed the database, it'll be fine tomorrow. We have a process for being able to put those back into for being able to take the changes that you want and make them permanent.
And how do you guys orchestrate that as far as the resetting the schema?
It's a Jenkins job that pulls from a clean instance. So we have a Postgres database that has the snapshot, and we do a dump and a push.
How do you do canopy testing when you have a database schema change?
Very careful. So we're able to do when we actually make the schema change, that's sort of outside of band for releasing Dockerized services. It's a careful manual process. We test it in dev, we test it out in QA, we try and prod process conditions. Any other questions? All right, thanks a lot. Yes.
Because if you want that, you can also.
Already, great. I'll let you guys start in a second. Let me just make a couple of quick announcements first. So, all right, so there'll be people coming in. I'm just going to make a couple of quick announcements, and I'm actually waiting for a couple more organizers to come in, because of course we have to give them their due. And we definitely want to do that. The workshops will be starting, hopefully, because I know it's a very aggressive timeline, in about 1:05. What we also have managed to get is basically another meeting room, and I've set up a sort of ad hoc space in that, down by the Sysdig room, there's that desk. So we have 4 extra slots in which you can hack with all kinds of other stuff that you've heard about in the course of the day, or any of the products that you've seen from the vendors, or that kind of stuff. So we will have a very quick, I'll try and be very military about this, session of suggesting and voting, so we can figure out what to do in those 4 other slots. So we're going to try and run through that very quickly. The other thing, well, there is some kind of justice, apparently. So Maria, our catering wrangler, just had a phone call to say that the building next to Panera's collapsed.
Oh,
so, well, no damage, but evidently if you screw up the catering, then somebody's watching somewhere. And,
Andrew, do you have an alibi?
Exactly. Where was I between the? No, I was watching. No. So there's Maria. Great. So there's Maria. We're missing one, but that's fine. Maria, come on up here. Boyd, you two, and you, Patrick, as well. And find Anastas. Get him. Right, because these are really the people who made all this possible. I'm hoping you're having a great time. Obviously, these are the people who made it possible. Let's give them a big round of applause. And this guy. Hey. There you go. Hey. All right, so yes, basically lots and lots of emails being sent out, me annoying the hell out of them at all kinds of the day or night. That's what it takes to make this happen. And if you want us to be, or other people to be motivated enough to do this again, and I really hope some of you enjoyed this to the point that when the email goes out for a potential one next year, somebody will say, yes, I'm crazy enough to want to help organize this as well. The way we get motivated is by people like you saying, thank you very much for putting this together. So either now or afterwards, if you enjoyed it, please tell us. That's what we're here for. All right, now over to log entries, and they will be saying something about what they do. Thank you very much, of course, as a platinum sponsor for being the ones with the biggest contribution here.
Thank you, Andrew. Hi, everybody. I'm going to do my best to make this quick also so we can keep moving. My name is Matt Kiernan. I'm the Product Marketing Director at Log Entries. This is Mr. Mike Neville O'Neill. He's an engineer at Log Entries. Log Entries is a log management and analytics tool. It enables you to centralize your logs in one place from any environment, any format. And the idea here is that by doing so, you can then query them, build alerts off of them, create charts and graphs, and better understand what's happening in your system. I'd say that common use cases for a tool like Log Entries would be application debugging, infrastructure monitoring, maintaining compliance and security standards. And when it comes to something like container monitoring, we think that logs play a pretty critical role. You may have your entire application running in containers, you may have just a few pieces of it, and the log is a pretty universal source of information. So you can be collecting logs from all of your containers and all of your systems outside of containers, and be correlating them in one place to better understand end-to-end what's happening. We've seen a pretty dramatic increase in people using Log Entries over the last year for container monitoring. And when it comes to Docker monitoring in particular, we're having a hard time.
There's so much data. One of the things about Log Entries is that it's a SaaS-based offering. It's very helpful to be connected to the internet.
This is a fair point. When it comes to the way that we monitor containers, we take an approach that's aligned with microservice principles. Instead of requiring you to install something, we offer up a container. You just pull it from Docker Hub. You spin it up with the rest of your containers, and it'll automatically start pulling logs from all the containers on your host. And as you add new containers, it automatically recognizes those and begins pulling logs and stats from those containers as well. You don't have to reconfigure it. 3 different types of logs that you're pulling from your containers. There's the application logs coming directly from the containers themselves. There are the container stats, so like resource utilization. And there's Docker events. Our container utilizes the Docker API to pull information like containers running or containers stopped. So with this information, plus with the logs that you're aggregating from the rest of your system, plus Log Entries' other features like Livetail, where you can query everything in real time or create alerts in real time, you get a pretty deep view of what's happening in your system. I'd say that the best part of all this is that Log Entries is free to use. You don't need a credit card to get started. You can start right away. And you just go to docker.com for Docker-related stuff. You go to logentries.com to check out Log Entries. I think that covers most of what I wanted to say here today. Unfortunately, we couldn't show you too much of the product. However, logentries.com can help you do that. I think that's it. Thank you, everybody, for your time. I appreciate it.
And I just checked, other people are online, so I'm really sorry. I don't know what happened there.
We like to self-sabotage.
There we go. I'm sorry. Thanks very much, guys. Thank you very much, Log Entries.
Oh my God, I'm just breaking the AP. That would not be a good way to end. Right, we are going to get started with the workshops in a second. There's another announcement I have to make because it would be unfair to the poor pizza delivery people. There is pizza outside, which is great for a hackathon. That's exactly what fuels all these hackathons. So feel free to grab a slice before you get started. All right. Suggestions. I would expect at this point that probably most of the people who have tables outside may want to suggest usage of their product. I don't know. But before we do that, actually, sorry, John, good point. I'm just seeing you there. We have some things to give away. So before we get to the voting, I know, where's Dave? Can I see Dave? Was he outside? Dave was here a second ago. Thank you very much, Anastas. So he was going to give away something, and this gentleman over here, John, was going to give away something else very cool, and I'll hand the mic over to you right away.
Cool. Yeah, my name is John Reeve. I'm here with Boyd Hemphill here, and we're from Stack Engine. If you haven't swung around by the booth, please do so. We're a Docker management system, really sort of help you get Docker into production. So composing your applications, deploying them, orchestrating them in production. So do check it out. You can download it from our website. We also have a Docker community that we're getting going. We've got quite a few folks signed up and getting some good conversations there. Free download, free to use, so do try that out. So with that, we have a pretty cool Lego kind of toy here. Sure, hold it up.
Hold it up. Which, the front or the back? Oh, that's the back.
I'm in marketing, I say the front.
Ah, the front.
Just kidding.
I have an idea.
What's that?
Ready? I'm going to throw them up and you're going to catch one.
All right, don't lose those leads.
Oh, no, they have to clean up.
Yeah, you're probably right.
Oh, no! Oh, yeah! You should have seen them practicing that.
If anybody claims that wasn't random. Yeah, sorry.
Eric Windish. He's
You've got to be kidding me.
No. Come on. You're going to give it back to the community, right?
He's thinking about it. Maybe. You can take it, Eric.
Do the right thing, man.
Peer pressure.
Huh? It's up to you. It's up to you.
Go on.
But if you feel good sleeping at night, it's okay.
Do you like Lego?
I could, but...
I tell mine to give away, so I'll let Boyd, why don't you put the peer pressure on yourself?
What am I doing?
I don't know. We're still peer pressuring Eric about whether he's going to accept it.
Oh, I did win it.
I don't have one.
Oh, all right.
I'm really hoping you're right. With the train? I can't believe that. Who wants a hat?
That looks suspiciously targeted. All right, the next one. Mr. Nielsen, up to you. Oh, we want this to be louder. Can I hold this to the mic?
Does it make any noise? Okay, well, I'll make this. You want me to help you at all, Dave? I'll make this pretty quick.
Okay, clearly I didn't practice that one,
really
did I?
cool. I don't know if you guys saw me spinning this thing around the room here, but it has a detachable head that's only attached by a magnet. And if you put it on right, it stays on. Apparently, BB-8 is one of the characters from the Star Wars movie that is coming out soon, so that's why the co-branding. I just liked it. I thought it was cool, so I thought I'd get it as a giveaway, and that's what we're doing. So my 30-second spiel is I'm with a company called Redis Labs. You guys probably know what Redis is, but in case you don't, it's an in-memory database that's used by companies like Twitter and stuff to be very, very fast for all sorts of things. What we are as a company is we offer it in the cloud as a service on Amazon, Google, Azure, and IBM Software. So we are actually running deployments on each of those 4 clouds. And you can go and, you don't need any special code or anything. You can go there and get a 30 megabyte account for free. And then if you use more data than that, obviously you start paying. But what's more interesting, I think, is that we have a product that you can run your own cluster on-prem or wherever you want to install the software. Available now in a container as a beta. And this will mean that once we're finished testing this thing out, you should be able to spin up as many Redis databases running as a service wherever you want. And that's again at Redis Labs. So if you're interested in that, let me know. But let's get on to the show. So I'm going to go ahead and just do a quick raffle. I'm not waiting for any more cards. You guys have heard that day and a half to do it. I'm not throwing them up in the air either. I'm not that fast. Is it this way? No,
no, it doesn't like
this
that
one.
one.
Is it this one? No, not that one. It's Eric Windish. Is it this one? It is not Eric Windish, I can tell you that. And it is John Gallo of Church Pension Group. Is he here? Go get him.
Whoa, yeah, I think you have to be in the room to win it.
No, hey man, he's a sysadmin. Sysadmins need some love, so we're giving it. We're giving it.
John. He's a sysadmin.
Yay! John, yeah, here you go.
He's on call. Sysadmin with a business card.
Yeah, sysadmin with a business card. Church Pension Group, New York is a local. 19th East Street on 19th East 34th Street. All right. So you missed the whole show. This thing is awesome. So you win this.
Play the music.
And play the music.
No, you do
Too
it.
late?
Yeah, too late. Maybe.
How about if you do it
no,
real
it's
quick?
locked and no. We're out of time.
Oh,
Try again. It's getting, the finger doesn't like your finger.
Like my thing.
Oh, he's stressed now.
Okay, here. Is this still playing music? Probably not. No, let's forget it. Whatever. Okay. Congratulations, you win. Yeah, come out, say hello.
Thank you.
All right, no worries. Great, no problem. But thank you very much. That was so much fun. I think we should definitely reserve some time for that. Voting or suggestions for the workshops. There's the classic ones, obviously. We're going to have the Docker 101 in this room. It's all written up there, followed by, after the coffee break, might run over a little bit, so we'll see how it works. Jonas doing a great one on Docker Compose Swarm and Machine. Boyd's doing the first one, and then over in the Sysdig room, as I said, there'll be Andrew Kennedy and Scott Hartzell doing Beyond the Basics. And I think, from what I understand, it'll be a little, whatever you want to do, but Andrew will give you many more details about that. Any other tools you want to play with or suggest?
And I want to mention that I guess we have 4 slots, right?
Yes.
4 slots that 4 winning suggestions will get a tile. We have a lot of tiles.
There you go, you track everything.
Like yesterday, line up on me here if you'd like to propose an unworkshop.
Otherwise, you can all do the standard workshops. There's
Boyd ones. Is there Stack Engine?
Is there are only 2 time slots?
There's 2 time slots, 2 spaces.
So I have to catch a flight, but if you'd like to go through how to monitor with CAdvisor and aggregate with Prometheus, you'll have to sit through Stack Engine 2. I can do that in about 30 minutes, sort of show you how that works, what that looks like, how it scales up and how it scales down. We can actually play with that together. So if anybody is interested in that, I'll write that up. And if you're not, you won't hurt my feelings. I don't have any.
Ooh.
Dead inside.
Yeah. All right. Oh, I've written it up, but you did it again. With the double vote. There's stuff on ballot box.
Yeah, I'm from Texas. We do
Yeah.
that.
Yeah. Going once. Ah! Oh, I thought it was going to be all over.
So this isn't meant to be self-serving or anything, but several people had expressed interest to us in maybe getting some help in bringing up a Deis cluster for the first time, just kind of helping them out, walking them through it, answering some questions. So if anybody wants to do that, we'll make ourselves available for that. And if not, then that's fine too.
Perhaps someone has a question they want answered, or they want something shown that others may step up, even though they might not be suggesting themselves.
Ah, there you go. See, you see that worked.
Okay.
No, almost going to
Building smaller Docker containers.
Oh, reducing the image size? Okay.
Okay. Can you write it down?
Yes, I'm doing that, yeah.
I couldn't do this, but if somebody knows Kubernetes kind of well, maybe wants to do a rundown of that.
Good suggestion. Did you see in the earlier slide that Kubernetes requires PhD?
Never mind that, never mind.
That's fine. That's a great question.
I'm new to Rancher. I'd like to learn how to set that up.
Does anybody here have sufficient Kubernetes experience to, yes, or, yes, all right, great. So we have people, cool.
Anyone else?
All right.
See any more.
Sorry, in the interest of time, I am going to call it there. So we have, we're going to have an interesting vote. Oh, there's going to be one loser. We have 5 suggestions, 4 slots. If you feel strongly about this and you don't want to do the other, show of hands, yeah. Oh, actually, just do a show of hands. That's a good point. So this is please only the people who are not considering taking one of the existing talks. All right, let's do the first one, Kubernetes. Wow.
I have 7 over here.
I got 7 on the left. 14.
All right, 14. Okay. CAdvisor Prometheus. 3.
I got 2 on the left. 3 on the left.
Yeah, I got 1, 2 on the right.
Okay, so 5. Deis. Setting up a Deis cluster.
2 on the left.
I got 4 over here.
Was that 5 as well?
I got 2 on the left.
Oh, 4, 6 then. Reducing the size of containers.
Oh, wow. 3, 4, 5, 6.
Okay,
7 on the left.
7 on the left, and you did?
5.
5. 12. Setting up Rancher.
Wow. 2, 3, 4, 5, 6, 7,
9, 10, 11?
11 on the left,
I think.
Maybe I
Hey,
should.
put your hands down if you're rancher employees. It's clearly it's clearly a winner.
Oh, okay, good winner. All right.
I really wanted to set
So,
Dave up there.
So we do have the still rancher people around, right?
Well, that's the big question. Yeah, I was looking for both of them because I thought they were going to suggest it.
I saw Dave and Darren leave.
So yeah, well,
Okay.
so this is conditional on us
Right.
actually having the people from Rancho.
So I can do the smaller ones, I guess, if nobody else will take
Okay,
it.
so let's do this by. It's gonna be tricky, but let's figure this one out. Days cluster. Yeah.
We have an issue with one of us needing to do this.
Okay,
Oh,
so
flip.
let's flip this around. All right. And then the other two, and this is the backup for Rancher. Who is going to sort of run the Kubernetes one?
Can I suggest
Yes?
something?
Yes, sure.
The Days people, we also have a lot of
So
so
we'll
put those two together, we will help all of them.
Okay. Wow, that's easy. Now we can do all of them. That was pretty simple. So let's wait on the Rancher folks. Let's see what they're doing. All right.
They're marquee and all that too.
Yeah, I know. So they are somewhere, but they may be in a customer call or something like that. That's why I put them last. So the way this is going to work, so what people who want to do Docker 101, they stay in this room. The people who want to start on the more advanced, beyond the basic stuff, go to Sysdig. If you want to do reducing the size of containers, the 12 of you who wanted to do that, the Rogers room, I'll leave them there. It's in another meeting room in here, and we'll have to. Huh?
There's no projector.
I would hope so. Otherwise, we have a projector, and we'll figure something out. But if we only have one projector, this could be tricky. The dais area, this is going to be full. They need a projector. So we're going to have to figure out what's in this room. So bear with us, but the dais, the area itself, dais and the dais area, doesn't that make a lot of sense? That's over outside the Sysdig room. All right, thanks very much.